Welcome to General Chemistry Mini Lecture Series, Lecture 23, Solution Stoichiometry. In Solution Stoichiometry, we are going to introduce the volume or molarity of a substance into these calculation schemes. So we can convert the volume or molarity of substance A to the moles of substance A, and then through the stoichiometry, convert moles of substance A to moles of substance B. And then further, through solution stoichiometry, converting the moles of B to volume or molarity of B. And of course, we can also convert from mass of A to moles of A to moles of B, then to volume of B. Or we can convert from mass of B to volume of B. We can do so many calculations. Let's work on one example. What volume of 0.32 molar hydrochloric acid is required to completely react with 25.8 milliliter of a 0.2080 molar sodium carbonate in the following reaction? Here is the balanced chemical reaction. So let's work on it. First, this is a key equation you have to remember. Molarity equals the moles of solute over liters of solution. Then the molarity can also be calculated using millimoles to milliliters. And from this equation, you should be able to develop two other related equations. Millimoles equals molarity times milliliter. Go to the other side, you see? Or find out the volume. Then you swap the two positions. Volume equals millimoles over molarity. So therefore, from this key equation, you should be able to write out two more related equations. Okay, start with what we know. 25.8 milliliter. We start from there. First, we are going to convert from milliliter to millimoles. And of course, milliliter, sodium carbonate, they are cancelled. And now, doing the stoichiometry using the balance equation, we are converting from millimoles of sodium carbonate to millimoles of hydrochloric acid, and use the coefficients in the balance equation. Now we should just have millimoles of HCl as the unit. So we have millimoles, and then in order to find out the volume, millimoles divided by the molarity. What is the molarity? It's already given. It's already given. So the molarity is 0.32 molar, and molar also means millimoles per milliliter. So now you see millimoles are also cancelled, and this milliliter is the denominator of this denominator. Therefore, it should become a numerator, which means that should be the unit for the answer, 33.54 milliliter. Another example. A 20 milliliter of nitric acid solution requires 22.55 milliliter of 0.1 molar sodium hydroxide solution to reach the endpoint. Determine the concentration of this unknown nitric acid solution. How do we work on it? First, of course, we have to write the balanced chemical equation. Again, start with the key equation. And also understand that molarity also equals millimoles to milliliters, because in chemistry we use milliliters and millimoles a lot, and even microliters and micromoles. That's the same quantity, molarity, okay, but three different ways to calculate it. And in this question, we are going to use the one in the middle, millimoles over milliliters. Start with what we know, as always. 22.55 milliliter of sodium hydroxide. We are converting from milliliter to millimoles using the molarity, and then convert from the millimoles of sodium hydroxide to the millimoles of nitric acid. And then in the conversion factor, you find out the coefficients in the balance equation. You see millimoles of sodium hydroxide, they are cancelled. Milliliter, they were cancelled a while ago. And now on top, you should just have millimoles, okay, to find out the molarity concentration equals millimoles over milliliter. And we already have millimoles divided by the milliliter that is given in the question. Whatever you have should be the correct answer. Should be 0.113 molar, and also molar can be expressed using millimoles over milliliters. Those two are the same thing. Another one. The concentration of a 2-liter solution is 0.525 molar. How many grams of sucrose are contained in this solution? In the key equation from this one, we can find out the number of moles. Okay, so molarity, that's given in the problem, times the volume also given in the problem. And now you see liters are cancelled. We have moles. And now we need to convert from moles to grams using the molar mass of the substance. And then that gives us 359 grams of sucrose. This is question number 1 in lecture 23. Let's work on this one. Understand the other ways of calculating that. So in this example, we are going to use the one in the middle. There are a couple of solutions. Let's talk about the first one. We'll start with what we know, 20 milliliter of HCl. We convert from milliliter to moles, millimoles of HCl, because we are going to use this equation right here. And then further from millimoles of HCl to millimoles of calcium hydroxide. And now we got 2 millimoles of sodium hydroxide. Okay, so from this equation, which is the same as this one, M equals millimole over milliliter, we should be able to rewrite this equation into milliliter equals millimoles over molarity, so that we can find out the milliliters. We already find out the millimoles from the previous calculation, and now divided by the molarity. Molarity is as the same as millimole over milliliter. Millimoles are cancelled. Milliliter is the denominator in the denominator, so therefore it becomes a numerator. So in the question, there are 3. The fewest number of sig figs is 3. So therefore, let's do the round off. We should have 13.3 milliliter of calcium hydroxide. Another solution, that should be an easier one. We do the same thing, start from 20 milliliter of HCl, converting from milliliter to moles of millimoles of HCl, then further from millimoles of HCl to the millimoles of CaOH using the coefficients in the balance equation. Now you see millimole HCl, they are cancelled. Milliliter HCl, they are cancelled. So we just have millimoles on top, and then we divide it by the molarity. Okay, so we have the millimoles on top already. Therefore, I just simply write 1 here. 1 times this value should be still this value. All right, and then the molarity, I just use millimole over milliliter as the unit instead of just write M. And now you see millimoles, they are cancelled. And milliliter again, that will become a numerator. So that should be the same answer. but I don't need to carry out two-step calculations. I strongly encourage you to really understand what's going on here and be more skilled so that you would save time on the test so that you can actually improve your test grade. Those are the additional quiz questions, and I will see you guys in lecture 24. Happy learning chemistry!